Hello and welcome to this tutorial on geometric series. Now, what are we talking about with geometric series? Well, hopefully you've seen before some arithmetic sequences and series. Now, arithmetic sequences are ones that have a common difference. We add or subtract the same thing each time. Like this sequence, I'm adding 2, adding 2, adding 2. That's an arithmetic sequence. An arithmetic series is when we add together or sum up all of the terms in a sequence. So we're adding all of those terms up together. That's a series now. When we talk about a geometric sequence, instead of a common difference, we've got a common multiplier, a common ratio. So with this particular one, instead of adding something each time, I'm multiplying each time. In this particular one, I'm multiplying by 2 to go from one term to the next. Now, I think you can probably guess that a geometric series is when we take a sequence and add up all the terms, the sum of all of the terms in that series, in that sequence. So, arithmetic, we're talking about common difference. Geometric, common ratio. And you can find the common difference by taking a pair of terms, and if you want a difference, we're going to subtract. 12 minus 10 is 2. I could take the next one. 14 minus 12 is 2. 16 minus 14 is 2. For a geometric sequence, take those pairs and we divide this time. So 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. So any pair of adjacent terms in the sequence, a geometric sequence, divide them and you'll find the common ratio. That's how we find that common ratio. Another little useful thing to bear in mind is that when we're talking about a geometric sequence or series, to go from the first term to the second term, I multiply by the common ratio. To go from the first term to the third term, I have to multiply by the common ratio, and then I multiply again. So it's like r squared. To go from the first to the fourth term, I'm going to multiply by r, by r, by r, and so it's like multiplying by r cubed. That bit of information helps you to get your head around what's happening as I go from each term to term in a geometric sequence or series. That may come in helpful later on. Right, main skill then. Main skill for geometric series is just substitution carefully into a formula. Here is the formula that you will get if you are studying IB and you look at the formula sheet. And it looks a bit confusing, but we've got the nth term of a geometric sequence. Then this bottom one here, this is for series. Okay, so if we want the sum of terms in a sequence, we're talking about the series now. Now, it looks quite confusing, but actually, this is the same as this, just rearranged. So you only need one of those two formulas. I think it's best to just pick one. I'm going to pick the second one there. I'm going to stick with that. This first formula there, it can be more useful because you can avoid negatives. But for the moment, I would say just pick one, pick the second one, and then we've only got one formula to deal with. Okay, we're going to substitute very carefully. We may find out that we have some negatives here. So what are we talking about? What does this all mean? So U1 is the first term in that series. R is the common ratio here and here. And then N is the number of terms in the series. Let's give you an example. Things will start to make sense very shortly now. So, find the sum of the first 12 terms of the geometric series 2 plus 6 plus 18 plus 54. Right, what we're going to want is to find U1, we're going to want to find R, and we're going to want to know N. Then we can put these numbers into that formula, and we should get an answer. So, the first term, it's 2. It's the first term. We're doing pretty well. R, the common ratio, Well, let's take any two terms and divide them. 6 divided by 2, which is 3. So our ratio, our common ratio is 3. Let's just check it is for the second one. 18 divided by 6, also 3. Okay. And then lastly, n, the number of terms. Well, it says the sum of the first 12 terms. So n is 12. Right. Now, all I need to do is take that information and pop it into my formula. So, let's put u1 here. There it is, 2. Then I'm going to put r to the power of n. Well, r is 3, n is 12. And then on the bottom, 1 minus r. Okay, a little bit of tidying up. Chuck it into your calculator, and you should get 531,440. I recommend checking you can do that in your calculator. Now, here's a very similar question for you to try. Find the sum of the first 10 terms of this geometric series. I recommend pausing the video now to have a go at this. And now, I will move on to a quick answer for that one. So, this series, our first term is 4. Our common ratio is minus 2 divided by 4, which is negative 0.5, minus 0.5. And then n, we're looking for the first 10 terms. So that is my crucial information. Now I'm just going to substitute it into my formula. And when we substitute those values in, type them very carefully, use your calculator, and that's the answer we should get. Right, let's mix it up a little bit, and this time, instead of finding an exact answer, I want to find a formula for the first n terms of this geometric series. I think, again, it's a good idea to pause, see what you can figure out. Can you find the first term? Can you find the common ratio? Can you find n? What have we got? What can you do? And then I'll go through the answers right now. Okay, the series is geometric, and the first term is 9, and the common ratio is negative 1/3. If I do negative 3 divided by 9, I get negative 1/3, and I could pick any pair again. What we're trying to find is n. So, got to be very careful with your substitution now. Substituting all of those values in, substituting the 9 in, where the 9 needs to go, and then substituting in r, which is that one there. Let's put that in a different colour. So r is going in there to the power of n, and we don't know n yet. And then on the bottom, we put the r there. Be very careful with your negatives. Over here, we end up with this. And dividing by 4/3, dividing by 4/3, that's the same as multiplying by 3/4. So I think you should tidy this one up. Multiply by 3, divide by 4. And we get to 27/4, multiplied by all of that. That is our nth term there, or our general formula. Okay. Same thing, really. It's just taking values, substituting them into a formula. Right. Let's have a look at one last example. And this time, we have some of the information, but we're going to need to go a bit further and use our graphical calculator to finish it off. Probably worth having a read of the question, seeing what you do know, and seeing where you get to. Pause the video, I would suggest. And I'll go through it now. So, what have we got? A geometric sequence has first term 5, that's u1, common ratio 2, that's r, sum of the first n terms. We don't know n, but we do know the sum of, so we now have this part. If we substitute all those values in, we end up with this equation. And solving this equation is not very straightforward, so I'm going to use my GDC, my graphical display calculator. And here we go. So, what I'm going to do is I'm going to use the table So I'm going to press on this calculator the number 7 and go into table. And then I'm going to put my equation here, negative 5 brackets 1 minus 2n. So let's go negative 5 brackets 1 minus 2 to the power of, and I'm going to put x in there. And then I'm going to go across and close the brackets. Now that I've got that formula in there, we're going to plot the table. So I'm going to press, actually, first thing I'm going to do is I'm going to set and see how many I want. Well, this is only going to give me 5 terms, starting at 1, ending at 5. I probably want, let's have a look at the first 20 terms. That should be plenty. And then I'm going to go back table by pressing F6, and I need to scroll down through this table until I find the value of n that gives me 635. So as I scroll down, have I got 635? There it is. The 7th term is where we get 635. And so my answer is that n equals 7. The sum of the first 7 terms is 635. Right, there's a few examples. Go off and practice it, try some examples of your own, and thanks for watching.